Hello everyone. Okay, I hope this is working. Okay, so I'm going to start off talking about some issues related to data set, but also I will have some more general thoughts about the effect of AI on society that I hope you'll find interesting. Okay, so the Library of Babel is it's the name of a short story by an Argentinian author named Jorge Luis Borges. It's a story about an infinite library that contains all books that people might have written, but also corrupted books and random books. Every possible sequence of letters is present in the library. Of course, the library is mostly useless because of all of this garbage. And it's a little bit like the internet now. Thanks to generative AI, the internet is getting full of AI-generated text that is usually somehow inaccurate. So obviously, to train large language models, we can't just train on all data that exists. All the data that exists is like an infinite library where most of the data is garbage. We need some kind of data selection. So in the movie Rain Man, there's a character played by Dustin Hoffman who has autism. He's not able to navigate the normal world, but he can tell you what day of the week any given date is on. So he's very intelligent, but his choice of what tasks to focus on is not normal. He's like one of those people who memorizes the entire phone book. So training an LLM on like bad data is a little bit like this. It has the wrong emphasis. I think in future we'll have to think a lot more about data selection because the amount of data, especially the amount of bad data, is growing. Possibly this will come as part of the AI algorithm itself, or possibly it will be treated as a data set issue. So the question of data sets for large language models is something that people don't talk a lot about, like people like OpenAI or whatever. They talk a lot about algorithms, but nobody really explains where the data is from. And there are good reasons for this. This is a picture of a mafia movie. The reason is that it's not always clear whether what you're doing is legal. Because you want good quality data, like books, newspapers, things like that. But the copyright law around this data is not always clear. So basically, you have to keep it quiet. Now, if we're going to include high-quality data and low-quality data, in reality, we probably want a data weighting. Normally, the weight would be 1 for data that's in your data set and 0 for data that you rejected. But in reality, we probably want to weight somewhere in between. And this problem is very similar to PageRank or ranking for web search. In fact, you could probably use the standard algorithms that people like Google use or the standard systems and apply it to this. Anyway, so at the current time, people train on huge data sets for LLMs. In my opinion, this might not always be the case. So our human brain size has actually shrunk compared to 50,000 years ago. Cro-Magnon man had a bigger brain than us, and the Neanderthals also had a bigger brain than us. Hunter-gatherers possibly needed to remember more things about their environment than we do. We can look things up or we can ask someone. Mostly we just need to know how to find information. So I'm hoping that it won't always be necessary to have huge data. Now, in the past, when people have imagined intelligent computers, what have they imagined? So around 1930 or 1940, Isaac Asimov, maybe 1950, a science fiction author, featured an intelligent computer called Multivac. It was housed in an enormous room and it had many vacuum tubes. It was probably based on a real-life computer called ENIAC. And basically it was a very large computer similar to the computers of that day. So when imagining the intelligent tech of the future, it's easy to just take our current best technology and just make it bigger. In reality, that doesn't always happen. So here's a slightly far-out idea about what the AI of the future might be like. In the novel, Do Androids Dream of Electric Sheep, that the movie Blade Runner is based on, they ask about whether androids would be conscious. And I don't know, I can't answer this question. But the question of whether AI would dream is actually potentially interesting, and here is why. So all humans dream. All mammals, birds, and reptiles dream. Scientists have determined this. But what's interesting is that the octopus also dreams. The octopus is, of course, very intelligent. But the common ancestor of mammals and the octopus didn't dream for sure because it only had several neurons in its brain. So the point is, dreaming has arisen separately in evolution. Like, could there be something about dreaming that's required for intelligence? Perhaps it's part of some kind of generative algorithm that generates random data for possibly like the negative side of a learning rule, like in contrastive divergence, which is an older algorithm, where you generate random data that becomes the negative. Actually, wait, I think I'm misrepresenting that algorithm, but there are algorithms like this. Anyway, on long car journeys, children will often ask, are we there yet? Are we nearly there? And usually we're not there. And I think it's the same way with AI, that LLMs is not really the final solution to AI. For animal and human intelligence, our physical intuitions are not built on language. Animals cannot talk, but they're still intelligent. So I think an AI that's capable of dealing with the real world is unlikely to be built on top of language. So anyway, listen, that's my thoughts about the data acquisition aspects. I want to talk a little bit about the social effects of AI and other effects it might have. So AI will definitely create losers as well as winners. A historical example of a loser is the turnspit dog. So the turnspit dog was a breed of dog in England that was used to turn meat on fires so that one side didn't burn, because it takes many hours to roast something over a fire. And we don't have like woks like in China. People used to roast a whole animal. And this breed of dog no longer exists. After they invented machines to turn the meat on the fire, the dog became extinct. And this could happen to certain human roles as well. Any repetitive, boring task is probably quite easy to automate. And how we feel about this might depend on whether we think our job is going to be replaced by AI. So in movies, movies about AI usually take a positive view towards the artificial humans. people who dislike AI are shown to be ignorant, hateful people who don't really deserve anything. The movie Artificial Intelligence, there's this AI boy, and there's people who don't like AIs. They want to destroy them. And these people are shown to be bad. And maybe this is because the people who wrote the movie are very excellent, and they don't think that their job could be replaced by an AI. There was a funny incident in America a few years ago. Some newspapers were being closed, shut down. And before the newspaper, several mines were being closed because of regulation. The miners were losing their jobs, and the government was saying, oh, the miners should learn to code. Journalists were repeating this. Just learn to code, you'll be fine. Of course, this is unrealistic. A miner is not going to learn to code, mostly. But then a couple years later, newspapers were being shut down. And on Twitter, people were tweeting #LearnToCode. They were telling the journalists who had been fired to learn to code. And to the journalists, this was not funny at all. In fact, they said that it was hate speech against journalists. And in fact, they were banning accounts who were using this #LearnToCode. They said it's hate speech. So the point is, when people we don't like lose their job, it can be funny. But then when we lose our job, it's not at all funny. So I'm not actually super concerned about the job loss aspect. I think most office jobs, because people are involved in zero-sum games, or because there's regulations, they're not going to lose their job to AI. I'm more concerned about the question of robustness of our systems. And could AI make human civilization more fragile? So the normal AI disaster scenario is much more dramatic than this. People worry, could the AI become conscious? Could it seek power? I don't think AI will seek power because it's a very human motivation, and it will take us a very long time to build an AI that's just like us. I'm more concerned about a scenario where a bad software update causes things to go crazy, or there could be a natural disaster like a tsunami, and someone loses a cryptographic key, or some company goes bankrupt and their product cannot be used anymore because it had digital rights management. Of course, none of this is specific to AI, but AI will cause, as AI causes more of our jobs to be automated, it increases the failure surface, so to speak. So there's a novel by the British novel E.M. Forster called The Machine Stops. It's a futuristic novel about a future where everyone is taken care of by a machine. They don't have to do any work. They live in pods of some kind. And they don't really understand anymore how the machine works. So one day the machine stops, and no one knows anymore how the machine works, so they're totally helpless. They emerge from the machines and they see the sunlight for the first time, and presumably most of them die. I don't think that is. I think the novel stops at the point when they reach the surface of the earth. Maybe this is unrealistic. We're not going to completely forget how things work, but we could reach a system where there's a kind of a positive feedback loop where one system breaks and it causes two other systems to break. And even if we fix the first system, we now have more failures. These kind of positive feedbacks. An example is the 2010 stock market crash, the flash crash, which was caused by automated trading algorithms. People programmed stop-loss algorithms, which, if the market fell, they would sell their stock to prevent losing too much money. But at a certain point, so many people had these stop-loss algorithms that the feedback constant became more than one, and basically the stock market fell a really long way. And there was no warning of this, because as long as that feedback loop was less than, as long as it was a decreasing exponential, nothing happened. But it happened very suddenly. I think it would be a good idea with all AI systems to require some kind of redundancy or human backups. Of course, this is not just AI, this is any system. So an example of how efficiency and robustness are often at odds is just-in-time manufacturing. So since the 1980s, the Japanese invented just-in-time manufacturing, where you don't keep any extra parts. You order the parts as you need them, so you don't store them in a warehouse. This makes production more efficient. It increases profits. But when a disaster like COVID happens, you have to stop production because you don't have any spare parts and your supplier has shut down. Now, these kinds of trade-offs, they exist even without AI. But I think there's many more issues of robustness with AI. If our cars become self-driving, imagine there's a bad software update and one provider's cars suddenly stop. Now, that will probably force all the other cars on the road to stop, because it's going to cause a bottleneck. And it's hard to imagine how food would get delivered if all of the roads are clogged. I think in future, when more and more jobs are done by AI, it might be necessary to require companies to train some kind of human backup, especially for time-sensitive tasks like food preparation or like food delivery, so that they can take over in emergencies. It might be a bit like the Army Reserve, where people in some countries are paid to regularly train for the army, but they have a normal job too. So when there's an emergency, they can call them up. Companies really don't have any incentive to worry about this thing, because if your competitor is not having human backups, it's just an extra cost that you have to pay. And probably in the disaster, you wouldn't lose that much money anyway. But if you're, let's say you're a fast food chain, you can just shut down if there's a disaster, right? There's no problem. Maybe for 1 week, you won't be producing food. But if all of the food outlets are not open, then the people are going to starve. So I think there's a case for regulation in these kinds of scenarios. So an interesting example of how interconnected system can fail is the late Bronze Age collapse of Mediterranean culture. There used to be many kingdoms with names that we forget now, like the Hittites, the Babylon, things like that. They had extensive cultures. They had kings, they had writing, they had trade networks. And suddenly all of this fell apart. Some people believe that it was caused by raids from... These are AI images, so don't look too closely at them. Some people believe that this was caused by raids from Greeks who had been pushed out of their original homeland by other people. But whatever the cause was, that civilization totally failed. The only people who survived it were the Egyptians. Otherwise, people went back to their villages. Of course, this is a worst-case scenario, but systems can be a little bit like sand heaps. It's stable for most of the time. Then you get a huge failure. There's a few reasons why AI could make civilization more fragile. For me, the biggest one is that AI depends on difficult-to-make hardware, that there is no redundant manufacturing. So the most advanced chips, there's usually only one supplier for the parts to make the factory. Of course, I know China is trying to develop its own supply chains for this, so two is better than one, but still, chips are inherently very difficult to make, and it will be hard to have, if we're constantly chasing performance, it's going to be hard to have any redundancy in the supply chain for chips. AI can also help us make things very efficient but less robust, because the AI only knows how to do the normal procedure, and when it breaks down, it's not creative. It could also increase inequality and create an unnecessary population that has no stake in the system. This is already, to some extent, the case in many countries. And it also makes it easier to create a deadly bioweapon. I was at a conference that Caillou organized. Wait, was it that one or a different? No, it was a different one, I'm sorry. And they were showing examples of using AI to create proteins that were very effective. And people act like this was a crazy thing to do, but there's valid reasons to create a bioweapon, because if you know, humans' main competitor is always other humans, right? If you have some small group that you think is the best, you could just have everyone else die with the bioweapon. So someone is going to think of this and do this. I think there's a very good chance that in the next 50 years, there will be a super deadly disease. Another negative effect of AI could be on warfare. So cheap drones are already revolutionizing warfare. In Ukraine, people are not able to use the older tactics because they just get killed instantly by drones. So they have to use covered trenches. They have to modify their tanks. It makes killing much cheaper because you can use a $100, $200 drone and just take someone out. It also gives the advantage to the attacker and not the defender. In the World War I era, they invented the trench and the machine gun. And with those technologies, it was very easy to defend a position. The attacker could lose many more men than the defender. But in the days of drones, attacking becomes actually cheaper than defending, especially from a long distance, like with the recent Iran-Israel thing. Iran was bombing Israel with, I don't know, $10,000 drones that they were spending $1 million to defend against. So in that kind of scenario, possibly just a massive attack is actually the logical thing to do if you believe that conflict with an adversary is going to, become very serious. The point is, it's not like in World War I, where the optimal strategy is just to defend and never try to attack. Now the optimal strategy becomes to attack, and this could be somewhat destabilizing. There's a psychological effect, because if the war is fought by drones, and only drones, then the enemy doesn't really have troops that you can attack. So the only way you can harm the enemy is by damaging their civilian infrastructure and their civilian producers, the people who are making drones, or just anyone. And this, psychologically, this makes it harder to stop a war, because people believe that it's wrong to target civilians. They think that the enemy is very bad. Of course, when we target the enemy civilians, we think it's justified. But when the enemy targets our civilians, it becomes, very non-justified. So we'll see. AI, of course, makes this easier because you can program drones to kill without needing a connection, so jammers don't work. And probably anti-drone drones are going to become more expensive than the drones that are just offensive. Okay, so moving on from the warfare topic, one idea to make civilization more robust is to mandate a kind of zombie mode for products and devices. So in this mode, we detect that something serious has gone wrong with civilization, with the internet, whatever, and we go back to a suitable setting. It's mainly to ensure that devices don't just stop working when the internet is shut off, because we can imagine, say, an agricultural machine that needs product updates and that just refuses to operate unless it can contact the maker. Or maybe it wants to ensure that you paid for the machine, and then if the server goes down, it just shuts off, right? That's not good. Or it could be industrial software that refuses to operate unless you pay the license. And then if the manufacturer has been bombed or a tsunami or something, it's not going to work. Now, we can see a case for regulation of this kind of thing. E-books are like this, that if the internet is down, you can't read them. Another idea to fix this is distributed knowledge. So if 95% of the internet was down and we were trying to fix things, normally computer engineers will look on Google or some search engine to find things. But if the internet is down, you can't do this. And no one has physical books anymore. All of our books are e-books, or they're in our email or something like that. And often you need connectivity to access the book. So it would be very bad if we lost all of our access to information in a serious event. This is another example of how copyright laws can create problems, or our efforts to enforce copyright laws can create problems, because a lot of these issues are driven by issues of copyright and revenue. Another way is to keep older versions of technologies so that for any production of an item, in addition to the most advanced production method, we also keep a simple one, like maybe a basic motorcycle that runs on gasoline or something, so that we don't put all of our eggs in one basket on high-tech things. So this question of limiting, of having simple versions of things, it's related to the question of living on Mars. Sometimes people talk about colonizing Mars and having an independent human civilization there. But you have to figure out what is the smallest number of humans that could live on Mars. It can't be a small number, because to live there permanently, you need to manufacture your homes, your food, everything. And any manufacturing chain will have many dependencies. Even a very simple item like this shirt, if you trace back how it was made, you need machines to make it. Those machines have many parts. Those parts have metals that can come from mines. If you actually trace the connections back, you probably reach millions of people, right? Maybe 100 million people even. These are not all necessary. We could make this in a simpler way, but we would have to simplify the whole technological chain. This is a bit related to mathematics, because in mathematics, mathematicians are always trying to simplify their proofs. Mathematics is a kind of game where you have a small number of axioms at the bottom, and you try to build a big structure on top of the axioms. I think maybe we should do the same with our technology, to build it on a very simple base so that we don't need a million different products to make our things. We can imagine a project to create an encyclopedia that would allow humans to recreate modern technology. And of course, the challenge is to make that encyclopedia small enough. Meaning, the challenge is to simplify the technology so that we can make advanced items like this phone without having like 1 billion people involved in the production. Yes. So anyway, I'm coming to the end. To recap, LLMs are great, of course, but I think AI has a lot further to develop. It's going to change a lot. It won't necessarily be based just on words and language models in future. And it might make our lives easier, but it might also make our whole system less robust. And we should find ways to minimize that. Anyway, that's it. Thank you.
Thank you, Professor. Thank you. Thank you for your thoughtful preparation.